Welcome to another homework assignment for Math 2 from CPM. Today we're going to do number 39 from Chapter 4 all the way through number 44 of Chapter 4. Okay, so the first set, if you have been in class these last couple of days, should be okay. It's asking you to actually factor the quadratics and then write out the product as your answer. So you should all be familiar with doing the box and the diamond. If you know how to do the box without doing the diamond, okay, that's fine, but you still need some sort of a organizer for it. And then for problems like problems like E and F, please make sure that you factor out a greatest common factor. So in this case, the difference between the greatest common factor between 7, -7, and -42 should be a 7. Okay, so when you factor it out, what's left over should be 1x squared minus 1x minus, oh my god, 9, 6, 8? I can't remember. 6. Okay. And then do a box for the information in the parentheses and a diamond for the information in the parentheses. And then as a final result, you should get 7 times something times something. Your actual product will be written in with the 7 on the outside. And the same thing for F. What does 6, 26, and 8 have in common? Well, the easiest one that I can think of would be the only one that I can think of would be a 2. So your GCF would be a 2. And then you would factor out the 2. And then whatever's left over, see, 2 times 3 is 6x squared. 2 times 13... going to give you 26 plus 4, and then you're going to do a box and a diamond for that part too. Okay, the part in green, and then as a result your final answer is going to have the 2 in front of it and whatever product you actually come up with. Okay, so if you have any questions still about these, please let me know, but they should be pretty easy to do. And then the hint for part D was, can you actually factor this one? So please remember the question says, if it's not factorable, explain why not. Okay. And then number 40 should be pretty easy to answer. Is the set of even numbers closed under addition? So that means if you add up even numbers, are you always going to get an even number? So your hint actually lays it out for you. 2 plus 4 are even numbers. And yes, you get 6. That's an even number. 8 and 6 are even numbers. You get 14, which is even. 32 plus 10 plus 4 is 48. Okay, that's an even number. So, and then it asks you is if you add up 2 odd numbers. If you add up 2 even numbers, do you always get an even? Yes. If you add up 2 odd numbers, do you always get an odd number? So here's an odd number plus an odd number. Okay, well there's your answer right there. So that's that question down here. What do you think? Do you see any patterns? Try some numbers on your own. You can try negatives and see if that works. The even numbers are closed under addition. The odd numbers are not. Can you explain why? So think about explaining why. What happens when you add something like 3 and 5? Why do you get 8? Think of what happens on a number line when that's the case. When you add 9 and 7, you get 16. What if you add 1 plus 3? You get a 4. So think about that. Okay, that was 40. Okay, and then 41 should be pretty easy to do, or setting up for x, finding a proportion. So it doesn't matter which one you use, but you must use the 10 and you must use the x. So a proportion would be like 10 over x equals, and then pick 2 numbers. You can pick the 4 and the 10. You can pick the 6 or the 15. You can pick the 12 or the 30, whichever you prefer. But then you must, in this case, you can cross multiply or find common denominators, whichever you prefer, and then find the value of x. And then if you are doing it correctly, you should get, let me see where my answer key is, because I forgot what the actual answer was for this one. What number is this? 30, nope. You should get x equals 25 if you're doing this correctly. Okay, so just check your work. If you didn't get that, you might not be using the right numbers, but you should be using a 10 and an x, that's for sure. Okay, calculate the area of each polygon. So I'm going to show you how to calculate the area for the small one, and then you have to do the big one on your own. Okay, so here's the small one, and what they said to do was, for the hint, divide each shape into smaller, easier shapes to find the area. So here you go. They actually split it up into a rectangle at the bottom, and then there's your triangle piece at the top. So now I'm going to fill in the pieces from the original, the small one. This was a 4, this was 10, this whole thing was 12, and then this part right here was, a 6. Okay? And then figure out what the pieces are themselves respectively. So let's see, if this whole thing is 10, then we have 4 over here, so this dotted line is 4. And then the whole thing from here to here, well, that's 4 because it has to match up on the other side. So that means this part must be an 8. Okay, so now you really have a rectangle and you really have a triangle. Your triangle has a base of 8. And your rectangle is 4 by 10, right? 4 by 10. So your areas, well, 4 times 10 is 40 units squared. I don't think this has, oh, this has inches, sorry. So this is 40 inches squared, because the 2 slashes on the little pictures make it inches. That's the shorthand for inches. And then, so that's 4 by 10, that's 40 inches, and then 8 by 4, area for triangle is half the base, that's 4, times the height, that's 8. So that should give you 16. So area of your triangle is 16 inches squared. Area of your rectangle is 40 inches squared. So total should give you, sorry, I keep forgetting that. I need to lift this up. Total is going to be 40 plus 16, so you get 56 inches squared. So your actual shape, area of this shape is going to be 56 inches squared. Okay, so look at that really quickly. And then once you find x, you need to do the same thing for the second one, this one right here. You're going to break it up into its pieces, the rectangle piece and the triangle piece. Find the area of both. Area formula for triangle is half the base times the height. Area for rectangle is just length times width, or the base times the height, and then put them together. Okay. And then, yeah, ooh, look, we got that. Yay! So you should get an answer 56 units for the small one, which we did. There it is. And then the big one has an area of 350 units squared. Okay, that's off of this website. Okay, and then 42, you're setting up proportions. I need to go faster because we're running out of time. So you need to set up for each part below, decide if the triangles are similar. If they are similar, use proportionalities to solve for x. What did the parallel lines tell you about the relationship between x and 5? Okay, I'm gonna go fast on this. If you're not getting this by now, we're gonna have some issues. So this is the side splitter theorem. You have a note card or you have a learning log for this. It basically tells you that 8 over 5 is going to equal 13 over x. Okay, and you can set up a proportion from there. And then B, the same thing, can you confirm they are similar triangles? So looking at this, this one, that one, that's kind of about it, actually. No, I forgot to put... there's not enough info. You don't have enough angles. The only angles... This is similar because of angles. So these angles are the same. These angles are the same. And then this angle is similar to itself. Okay? But these ones, the only ones that you do know for a fact are the same angles as this angle and that angle. And that's it. You need another set of angles to be similar. And these two top ones are not. Okay, so there's not enough info for this. And then which angles are similar? Okay, well, there's your vertical angles. And then you have the interior angles that tell you those are the same. Interior angles that tells you these two parts are the same, or these two side angles are the same. So they are similar, and now you need to pair them up. Okay, so 8 and 6, because they're both within those parts, and then x and 4. So looking more closely, you need to write a proportion using x over 4, and then maybe 8 over 6. Or maybe 4 over x equals 6 over 8, or whichever way you want to do it. Okay. And then the second to last one, it says, Jim and Joan are planning a dinner menu. They have a bunch of food that they can try out. Jim and Joan like to know how many different dinner menus you have to choose from, and CPM is actually pretty good about putting out different types of ways to look at it. So they did it out, and then they did kind of like a tree diagram. So you have steak and then brownies, steak and ice cream, steak and chocolate, or you have tuna casserole and brownies, tuna casserole and ice cream, and then going from there. Each ones are pretty different. So this is your tree diagram, or something like a diagram. And then this is just writing a list of what you can have, and then it says how many different menus are there. Well, you can look at it. There's 3 here, there's 3 here, there's 3 here, there's 3 here, so that gives you a total of 12. Or since you have 4 main dishes, 3 desserts, 4 by 3 is going to give you 12. Okay. Assume the main dish choice and the dessert choice are both chosen randomly. Are all the menus equally likely? So, I mean, there really isn't a set possibility or set probability for each one, so they should all be equally likely. And what is the probability they pick a menu without meat? So, looking at all of these, which ones are without meat? Well, as far as I know, it says vegetarian lasagna, and they wrote just lasagna out here. So the only ones that are without meat are all the lasagna dishes, and all the lasagna dishes. Tuna casserole has fish in it, so technically that's meat. Turkey burgers have meat, and so you only have 3 of them, right? You only have 3, and you technically have 12 types of menus that you can make. 3 out of 12 or 1 out of 4. So there's a 1 in 4 chance, or 25%, that they're actually going to pick a menu without meat. Okay? And then you need to do the same thing. What's the probability they pick a menu with chocolate? Okay, where are all the chocolate ones? Here's chocolate, here's chocolate, here's chocolate, here's chocolate. Okay, so that's 1, 2, 3, 4. 4 out of, well, again, 12, right? So there's a 1 in 3 chance that they're going to pick a menu that has chocolate chip cookies. Wait, is brownies chocolate? Brownies have chocolate in them, don't they? Okay, that changes. Brownies are chocolate. Brownies and brownies. So this is going to be 8 out of 4, or better known as divide by 4. 2 out of 3. There we go. Because I'm assuming the brownies have chocolate. Chocolate brownies, yes. Strawberry ice cream, chocolate chip cookies. Okay. And then the last one, yay, I might make it under 15 minutes. Complete a table for the function x squared plus 2. So they actually set up some numbers in the hints for you. Try -3, plug it in, try -2, plug it in, and go from there. One thing I will caution you is, please make sure that you actually put a parentheses around the number. So for example, if you're plugging in a -3 on the calculator, you need to understand that -3 squared in parentheses is actually a 9, not -9. Plus 2 gives you an 11. Okay, so this answer is what they got right here. And you need to do that for all of them. And then do for 2, 3, and then 4 if you need to. Okay, and I would recommend that you should, actually. And then graph it. And you should get something, I'm just going to be honest with you, you should get something that starts at 2, okay, and then goes up in this direction like that, okay? And then tell me what type of graph is that, because I know most of you should know by now. Be sure to label the axes and include the scale. So do a scale if you're going up by 1s. Do a scale if you're going up by 2s. You need your y and your x, and then go from there. Okay, yay, and we're around 15. All right, if you have any other questions, see me during tutoring or during lunch. Bye-bye.